Hello, today we're going to start section 9.1, Rational Arithmetic. The objectives are to simplify rational expression, multiply and divide rational expressions, and add and subtract rational expressions. Part 1, Simplifying Rational Expressions. As with numerical fractions, a rational expression is said to be simplified or reduced if its numerator and denominator have no common factors other than plus or minus 1. To simplify a rational expression, you should factor both numerator and denominator and then cancel shared factors. Reminder, factors are attached to each other by multiplication. Terms are attached by addition / subtraction. And cannot be canceled or reduced in a fraction. Simplify the following expressions. A, x squared minus 2x plus 1 over x cubed minus 1. X squared minus 2x plus 1 is one of those special factors. This is a square of a binomial, so that factors into x minus 1 squared. Then x cubed minus 1 is another one of those special factors, difference of cubes. And that factors into x minus 1 times x squared plus x plus 1. Now, in order to simplify this one, I am going to rewrite the x minus 1 squared as x minus 1 times x minus 1. So because of the multiplication here and here, we have two factors on top, two factors on the bottom. And the common factors, x minus 1 and a single x minus 1 on top, cancel out. And we're left with x minus 1 over x squared plus x plus 1. And that fraction is reduced. B, 2x squared minus 3x minus 20 over x cubed minus 2x squared. 2x squared, since 2 is not a perfect square, doesn't fit our special factoring rules. So this one I'm going to use the AC method. So AC equals 2 times negative 20, or negative 40. Then my factor pairs. Because it's negative 40, are going to be positive and negative. But because I want it to add up to negative 3, the bigger number has to be negative. So it's going to be 1 and negative 40, 2 and negative 20, 4 and negative 10, 5 and negative 8. And that is it. So 1 and negative 40 is negative 39. 2 and negative 20 is negative 18. 4 and negative 10 is negative 6. 5 and negative 8 is negative 3. That's the one we want. So 2x squared minus 3x minus 20 becomes 2x squared plus 5x minus 8x minus 20. Then, grouping it, I can take an x out of the first two terms, get 2x plus 5. And we can take a negative 4 out of the second two terms to also get 2x plus 5. And then we get 2x plus 5 times x minus 4. So that's what the top factors into. Then the bottom, x cubed minus 2x squared, they have an x squared in common. So I can factor an x squared out, and we're left with x minus 2. Well, we have 2 terms on top because of the multiplication here. And then since x squared is x times x, I'm going to just leave x squared this time, times x minus 2, we have 3 factors on the bottom. None of the factors match, so b cannot be reduced any further. C, 3xy plus y squared. Well, I can factor a y out of the top. We get 3x plus y then. And then 2y is already 2 times y. So we have 2 factors on top and 2 factors on the bottom. The y's cancel out. And we're left with 3x plus y over 2. D, 4x squared y minus y cubed over 2x squared y minus x y squared. So on the top, they have a y in common. So we get y times 4x squared minus y squared over, then on the bottom, they also have a y in common. And we get 2x, sorry, I made a mistake. They have an x and a y in common. So I can take an x and a y out. Then we get 2x minus y. Now at first glance, it looks like only the y's can cancel out. But before I reduce anything, I notice 4x squared minus y squared is a difference of squares. So even though I factored it once, I can factor it again. So by difference of squares, we get y times 2x minus y times 2x plus y. Over xy times 2x minus y. Now I can see the y's cancel out and the 2x minus y's cancel out, leaving us with 2x plus y over x. Note, it is always best to leave the denominator of a rational expression factored. Sometimes you do want to multiply the numerator, but always leave the denominator factored. And that's it for part 1 of section 9.1.